Okay, so welcome back, and I apologize. Probably if you have been watching, this series, then you probably noticed that I missed or skipped a Saturday. I apologize. So we're right in back with the curriculum, and we're at 2.2, so at databases. And again, we're going to talk about this from a very high level before we jump into actual programming. Just to make you aware of what are people talking about and where, what basically, what kind of conceptual understanding is helpful before you jump into that. So let me see where we've been. There we are. Okay, so we're going to go through four very basic questions. The first one is, I think, most obvious for most people, but nonetheless, let's talk about the concept of what is a database in the first place, and why and when do I need it. So every program you run, and of course a web application is no exception here. Every program you run has something that is referred to as state, which basically means that you handle particular views. So which page are you on, for example, in a single page application, but also it's a constant flow of data. So if you look at something like something flat, so when you say like, okay, I've got a company that has like a little page, business card page where it basically introduces itself and so on, then that's relatively easy to achieve with just writing HTML, for example. But relatively fast, you will have additional needs. So what if you want users to be able to be remembered, so to log in somewhere? Or what if you want to enable somebody from the company to change the content on the page without the necessity to actually code? And even for you, for if you're creating stuff just for you and you are able to code, maintainability is something that eventually will just take up too much time, and you get to the point where I say, like, I wish it would memorize a couple of things and could be more dynamic. So whenever we basically store data, we want to have that data accessible, and more importantly, we want to have a possibility to ask for particular data depending on the needs of where we're currently at in executing our program. And this is already something that is relatively clear. So let's look at something like local versus remote. When you say, okay, so in theory, if you have an app on your phone, let's say, most data could be stored on your phone. It's not necessary to store this data remotely. But if, for example, you think about something like an email, where you say, like, okay, so I'm sending out a particular set of data, in that case, the information in the email, and maybe somebody has to log in and get that email back. So emails don't really work with a classical database, but the principle is exactly the same. So you need to make sure that as soon as you start sharing data, that this data is somehow either stored on a remote machine for purposes that for example, you want to share it with multiple people, or you somehow ensure that you can directly talk to the other person's device, which is an interesting concept when we talk to peer-to-peer networking and end-to-end encryption. And I mean, there's a lot of things that work like that. But in the most basic principle, normally, let's say I write a post for Facebook, I write something, it is then stored on Facebook's database. And so next time, I open, or somebody who is allowed to view that content will be able to simply see it on their wall or messages or whatever. So that said, there are design decisions on what you want to have stored locally and what you want to have stored remotely. So when you, for example, start to fill out a form, and like your phone suggests, say you probably want to use your email, then that email might as well be stored locally. I mean, it's not exactly how Google handles it, but I mean, it would be perfectly sufficient to simply store that information on your device and then basically recognize that, okay, now we want to use this kind of data that we memorized. While in other circumstances, you say, no, we are going to store this remotely because we want to be independent of a device. We want to share, we want to access, we want to further work with the data beyond the actual use of the device. And this is already going into security. As a rule of thumb, you can of course say like, well, whatever's stored on your device has a higher security than what's stored on a server. And that is just true if in percentages. So in theory, the very secure environments store information more safely on the server than your device would be. On the other hand, as soon as you can access it with a device, so if your device should be like compromised of what any kind, and you gather that information, then that information would be gone either way. So the decision what we save locally or what we save at all, or what we just memorize, at runtime, for example, like which page we're on. I mean, that's not necessarily something we want to remember for the next login, but maybe we do. I mean, that depends. Or we store it more persistently. That's all a question we're gonna look into like way later. At the moment, we need to make the distinction between relational databases. So those are like SQL databases, Postgres. I mean, there are a bunch of possibilities, and non-sequential databases, which or they're normally referred to as NoSql database, and what that exactly means. So let's look at that maybe. First of all, what are the differences between client-side and server-side? So this is nothing else but local, so on your device, and this basically means remote, right? So on a server. And here are a couple of common possibilities to store data on the client. Local storage, that's a relatively simple form of basically it's a super cookie. IndexedDB is a very smart client-side database that is very interesting for applications that you run. Like single-page application stuff that heavily relies on the client when it comes to functionality. And the most classical form, cookie. Now, cookies are not really a database in that sense, but nonetheless, you can use cookies, of course, to store data locally and access it smartly. The lookup is just not meant to work like a database. So that's, I mean, again, what we're going to talk about is like, okay, how do I access data? And we're going to get to an example in the next slide. Server, also relatively straightforward. Well, SQL or any kind of SQL variation, so MySQL, you name it. Postgres is basically the same. MongoDB is a NoSql solution that runs on a server, and those are basically when you hear those terms. That's how you basically have to think about them. Like, okay, so in which category do they fall when it comes to storage and where the storage happens? But to understand this a little bit better, let's look at how data could potentially be stored, right? So here we can basically look at, so on the left you see a relational database. So what we have here is something that we would call a table. And if you imagine data, you're probably familiar with spreadsheets in general. So imagine this to be a spreadsheet, and those would be the columns, right? I mean, we call them fields, but it really doesn't matter. So you have a field ID, you have a field name, and you have a field created at, right? And now you would have a list that will basically say, okay, ID 1 is John, was created whatever date. ID2 is Sam, was created at whatever date. And you can look those values up by depending on what kind of database you use. So let's just assume classical SQL. You would basically say, okay, please show me everything that was created, after November, for example, right? Or give me the particular user with the ID. I know the ID. Let's say give me the rest. Give me the name, and when it has been created, and so on. So the whole idea of database is to perform what we call queries against it. So ask the database particular questions and get the result out. And so here we have something else that's a comment. So same thing. So imagine you have a second tab in the spreadsheet. So now you have an ID that from the comment, and you have a user ID. And then you have a content. So let's say this says, okay, comment 1 would be by user 1, and then by has the following content of text, whatever. And then again, you have a list of that. So now how do you basically combine them, right? And that's basically what a relational database is intended to do, is to say like, okay, so here now I get all the comments, but for example, I'm missing the name. So how do I know what the what the name of this user is? Well, in that case, I can simply basically say I want to ask for this information additionally. Like in SQL, that would be a join, or I can retrieve the data extra. But I have the information which user is basically wrote this comment, and this user ID directly references this ID, and therefore I can look it up and make smart decisions in that either way. I can also say, well, from the user's perspective, I would like to have every comment this user ever, or a particular user ever wrote. So I get the particular user ID. Let's say I know this name is Sam. So let's say, okay, give me the ID of Sam, and then find me all comments with the user ID of Sam. So let's say that's 1, and then I get a particular list out of comments that Sam wrote. And basically this is also easy to understand when we talk about one-to-one or one-to-many, or even many-to-many relations, right? So here we would have basically it is very, very possible that there's one user, Sam, that has written multiple comments. So I would get now multiple comments out for one particular user. Now, in the NoSql approach, basically data is always some form of object, which basically means, well, the user has comments as a something we call property, and here is a list of comments. I mean, I don't want to indicate an array, but this is a list, so this could also be many, of course, and I can then directly get to all the comments of a particular user. Now, in a NoSql approach, it's not necessary to work like this. So there are possibilities to basically get the same kind of functionality out. But the pure idea is, and that's why I show it like this, is to basically say, okay, so like comments might or might not exist on a particular user. So I have a particular user object that has sometimes a hard structure, sometimes a very fluctual structure, and contains information that would normally live somewhere else directly in the object itself. So the reason why people like that, I mean, something like MongoDB is in the Node.js world, for example, pretty popular. The reason why people like that is because they have all the information directly on where they want it. Now, the more advanced you become in programming and the more complex your applications will be, the more you will notice the problem with such an approach. And you would then, even using something like MongoDB or any NoSql solution, would then basically, instead of having the information directly in here, more or less write your relations in here. So give like a hint of, okay, which comment should I additionally ask for now in order to fill the list of comments. And by the way, in order to overcome this, if you should ever work with such a solution, that is why you normally see that the IDs have a weird markup. I mean, something like underscore ID and so on. Because IDs are not a property, but something that the system itself basically puts on it, right? Something that I have a lot of possibilities to decide how that behaves in relational databases, but the principle is the same. So what is here an underscore ID is something that the database itself gave the user. This is the next user number, basically. So to make sure that this is a unique identifier. So because we can't have in either system, we can't have two users with the ID 1, right? That would be very confusing, because then how do we connect this information accordingly? So in most scenarios, you work here with something like a JSON. So you get that out as basically something that you can directly work with, and that is basically directly data that you can then access in your business logic. And that's why people like it, because they don't really have, or they usually don't write very complex queries to put together the set of data they need to work with. And again, this is very good to start with. It's also it's not that it's not a scalable solution, but when it comes to maintenance and how you work, there's a reason why the more advanced applications tend to use a relational database. And this is an opinion, so I mean, take that with a grain of salt. But I don't see any reason to, even as a beginner or for prototyping, to use NoSql. When you want to start to use something like this, it is very easy to pick it up. So to go from relational to something like, okay, I want to be able to do this, is pretty easy. The other way around is sometimes a little bit difficult. So I would highly recommend to start learning a relational database system and then switching over. And I know that with modern stacks, I mean, most people nowadays say like, well, why don't you use Node.js? You only need to learn JavaScript and nothing else. And then the way they like you would want to work with something like MongoDB, because it's just more suitable to it basically directly translates to a JavaScript object that you can work with and so on. So it's very useful to start. I understand that, but it's not that this is very complex. And if you really start understanding how relational databases work, the advantage is pretty high compared to the slow advantage of having a faster start over here. And again, this might still be a good solution one day. That's not what I'm saying. What I'm saying is that to learn from relational to NoSql is rather simple compared to the other way around. Yeah, that's basically what I want you to understand prior, to before we actually jump into databases. Let me think if we want to. Let me actually show you. Let me show you something here. Do we have something like a Maria or? Oh, you know what? I'm just gonna have the PHP-admin open. Okay. Oops. Weird. Okay. So this is to just show you how something like this could look like, and I apologize, it's automatically in German for me. So if we look at, I don't actually know what kind of database this is. So this would be a database, and the database has, in that case, two tables. Oh, that's actually a very simple example. So task and subtask. So let's just look at the list of tasks that we have. Oh, God. Okay. It doesn't have an index. All right. It's probably not the best example, but so here we could see basically, okay, so it generates a list of IDs, and it has a name, and then there's a flag. Is it done or is it not done? And in that case, it also has a delete date, so a task, I assume, can be deleted. And in the subtask, which appears to be empty, It is. So let's look at the structure. Okay, so you see there's a task ID, which would directly relate to the tasks that we have. And I could actually, you know what, let's look at something else. Not sure what I can show you here without compromising anything from clients. Oh, perfect. This is as simple as it gets. Okay. So here we have a user, right, with a particular ID with a username. And there's also another table. It's called user email. And then the big question is, okay, how would I connect those two, right? Or user password. So I could, for example, have multiple emails now, right? If I change my email, for example, that might make sense. So let's say I retain the old email. The user wants to change his email address. So he changes the email address. You send out a confirmation link. So until that confirmation link is confirmed, the old email is still valid, right? And actually, this is exactly what you see here. There's no confirmed date, so this is probably not a valid email, which, it isn't hard to guess. So that's basically how those tables would look like. So again, if you think of a spreadsheet, that's basically how you can visualize it. And if you imagine how would would you put your object together? So what you normally do is you query together what you need and then get back to something that would. So even if you're working in this context, what you do is that it's pretty likely that what you end up working with in your code should look like this from the structure. I mean, maybe not this example is actually not a good example, but that you would work with one particular subset here. Yeah, and that basically concludes today. So thank you for listening, and I understand that this is very high level for now. Those kind of topics are basically just little brain teasers in order to enable you to understand what we want to talk about later when we actually start coding. So you need a little bit of an explanation, a little bit of whiteboarding if you want, so in order to understand what is happening, because we don't ever have to see, like, actually this, what you see here, this PHP My Admin in that case, that's something that you really never need to look at. It's just helps you to verify what the setup of your database is in that case. And that's basically it for today. So I'm gonna try to speed up the process, and tomorrow record the rest of this section. And I hope I could give you some clarity. And I can't wait to jump into actual development with you guys. You enjoy your weekend.